Good afternoon, morning, or evening, Math Foundations people. We're going to be looking at the circular functions sine and cosine, or sinusoidal functions today. Okay, so last day we looked at radians and degrees, so this is kind of similar. We're going to be looking at radians and degrees in the two sinusoidal functions, sine and cosine. Y equals sine x, y equals cosine x. And what we're going to do is we're going to be looking at basically the basic shapes and the similarities and differences between the two and how they're formed. And that's what we're going to look at today. Okay, we're going to draw a few pictures and have a few graphs as well. We'll use Desmos again just to look at the basic shape of the graph. Okay, so let's outline what we're going to do today. Okay, so this is day 8. We're looking at unit 4 here still, last unit. And we're going to be looking at, basically, we're going to look at the circular functions. Of y equals sine x and y equals cosine x. Okay, we're going to be looking at how you get them or develop them. And then we're going to look at the similarity and differences. And then we'll be looking at shifts and things like that after. Okay, so the first thing is, let's take a look at the circular function here. So let's draw a big circle. Okay, and if we break it into the coordinate planes as well. There we go. Close enough. Okay, so there is our circle. So what we do is, if we look at a particular point in the circle, any place in the circle, we can relate the angle measurement, either in degrees or radians, doesn't matter, to the y and x component of a triangle that's going to form. So if we drew a line, say we'll do it right here on this quadrant right here, at this point, let me get my marker here first. Okay, maybe we should use green or something. So let's say we had a point here, x and y, on the circle. Could be any of the quadrants. Okay, and if we were to draw a green line out to it, from here, okay, we could draw the projections along the x-axis here. That's black. We have to need a different color. Okay, we can project right along the x-axis, right to where that dot would be, approximately there. And that would be our x part. And then we could do the same kind of thing, projecting upwards. This would be our y. So here we have an angle, we'll call it theta. Right here. And it relates to the x component, which is, that's hard to see. Let's use black here. Stick with the little black. The yellow one being x, and the orange one being y here. And this green one we call as the radius. So later on, when if you've done any pre-cal, you'll know that the radius, we can do a unit circle and say, hey, the radius is 1. So if the radius is always 1, we can and say if the radius of the circle is 1, one unit, they call that the unit circle, then we can have ratios for x and y according to as it goes around. Now, if we swing this around, you can see that here x would be long and y would be 0. And as we come up, y gets longer here and x gets shorter until you get to this up and down position where you just have the yellow line. And then as you swing down to here, it would be going backwards, but x would be extending, getting longer and longer and longer, and y would be getting shorter and shorter and shorter, and so far as you swing around here. And we can see that, let me just pull up my preview here. We can see that with an animation here that I'll just put up. Just give me a second to get it set up, so I'll just pause and grab that animation. Okay, so here's a thing off Khan Academy, which is a good math little thing. And so here's our unit circle here. And this guy is going to rotate this green vector, the radius of this one circle all the way around. And you'll see that this white dot, or this green, this yellow dot will go up and down here. And we'll just listen to him for a couple minutes here and see what it looks like.
What we're going to do is we're going to construct something that looks like sine of omega t. So we have our function of time here.
Don't worry too much about that.
And we have our frequency. Now this little animation is going to show us a way to construct a sine wave. So what I have here, this green line is a rotating vector. And let's just say that the radius of this circle is 1. So here's a vector just rotating slowly around and around. And in the dotted line here, in that yellow dot going up and down, that's the projection. That's the projection of the tip of the green arrow onto the y-axis. And as the vector goes round and around, you can see that the projection on the y-axis is bobbing up and down and up and down. And that's actually going up and down in a sine wave pattern. So now I'm going to switch to a new animation, and we'll see what that dot looks like as it goes up and down in time. So here's the plot. Here's what a sine wave looks like. As you notice, when the green line goes through 0.
Okay, so you'll notice that he's got 0, pi, and 2 pi, and that is the radian measure around a circle. Okay, so if we were doing that in degrees, remember that 2 pi radians equals 360 degrees. This would be 360, this would be 180, this would be 0. And this is the shape. He's plotting y versus the rotation of the vector here. And he'll do this for cosine as well, which is another shape that we'll look at.
0 right there. Let's wait till it comes around again. The value of the yellow line when it goes through 0 is 0. So this yellow line here is a plot of sine of omega t.
We just use theta.
Now, if I go to a projection, this projection was onto the y-axis, and I could do the same animation, but this time project onto the x-axis, and that'll produce for us a cosine wave. Let's see what that looks like.
Similar thing.
Now, in this case, if we switched over, you can see that the projection, that dotted green line, is onto the x-axis. And what this is doing is it's producing a cosine wave for us. So this is going to be cosine of omega t.
We're going to use theta, but don't worry about the omega t.
Now, because we're tracking the progress on the x-axis, the cosine wave seems to emerge going down on the page. So the time axis is down here. When the green arrow is 0 right there, the value of the cosine was 1. And when it's minus 180 degrees, it's minus 1 on the cosine. So that's why this is a cosine wave. And it has the same frequency as the sine wave we generated. And now I want to show you these two together because it's just sort of a beautiful drawing.
Okay, so this is both of them changing at the same time. Sine, the x and y components of that vector.
I'll leave our animation here for a second. We see our sine wave being generated in yellow, and in orange we see the cosine wave being generated, and they're both coming from this rotating green vector. So this is a really simple demonstration of a way to generate sines and cosines with this rotating vector idea. We're going to be able to generate this rotating vector using some ideas from complex arithmetic and Euler's formula.
That's not for us. We'll stop there. Don't have to worry about Euler's formula. But that gives us a good idea. We'll get that out of our way here. Of what we're going to be looking at in terms of sine and cosine. Okay, so now if we're going to relate that to this angle theta, we're not going to use the WT idea. We're going to just use theta. So you can see as you're going to rotate this green line around, these lengths of x and y are going to change. And what we know is that sine is the relationship between y and r. So sine theta, I think I was already there, sorry, is going to be equal to y over r. And if r is 1, it's just y. But r isn't always 1, but in our case, we're going to assume that it is. But it could be something else other than 1, depending on your, cosine I got to do. And cosine is the value of the relationship of x over r. Okay? And tangent is x over y, or y over x, pardon me. But we're not going to look at that for a little while yet. Okay? X over y, x over r. Get myself mixed up here talking about tangent. X over r. Okay, so there's our two relationships. And as they go around, depending on what r is, y and x will always, as we know, x squared plus y squared equals r squared, as well by Pythagorean theorem. Okay, for this right triangle here. And that'll change as you go around. Now, this part here, this is the first quadrant here. And we know that x is positive and y is positive, right? Both are positive. X equals a positive, y equals a positive. Okay, in that first quadrant. In the second quadrant here, r is always considered positive. In the second quadrant, x is going backwards, so x is considered a negative value, and y is considered, because it's going up still, a positive value. And again, r is equal to a positive always. That hypotenuse squared, so that r always ends up being a positive value. Okay, if we go into the third quadrant, it's going backwards and down, so both of these are considered negative. And r is still a positive, and that's in our third quadrant of our circle. And if we're going to talk about what they might be in radians and degrees as well. If we look at our fourth quadrant, x is positive, again, it's going forward. Y is a negative because it's going down, and r is a positive, as it always is. Okay, so if we're looking at these points here, if we did degrees, this would be 0 degrees. Sorry, not theta. 0 degrees here, 90 degrees here, 180 degrees here, and right at the bottom, I'll have to move this a little bit, is 270 degrees. And as we come back, this would be 360 degrees. Okay, that's the degrees of that circle. Now, if we're looking at radians, okay, radians, so you can see the 2 pi is all the way around the circle. We know that. So we'll do radians here in a different color. So if we have 0 radian, okay, this one here is pi radian. Okay, so this is halfway in between, so this is half a pi. 90 degrees is half a pi. So we write that as pi over 2. And this is 2 pi over here as it comes back. So halfway in between 1 pi and 2 pi is 1.5 pi, and we write 1.5 pi as 3 over 2 pi's. Okay, if we're doing an improper fraction. Okay, so these are radian measure. And then the black would be the degrees, which you are more familiar with, I imagine, in your math. Okay, so as we go around, we are going to get that shape that he showed us in the animation. So if we go to Desmos here, and we can just look at the basic shape of the sine and cosine graph. Okay, so I'm going to bring Desmos here into it. Okay, and we'll summarize our notes as we go. Now I'm going to click here on this, and you can see I want it to be in degree. We'll do it in degrees first. So we want a whole circle. A whole circle is 0 to 0 to 360 degrees. So we'll put along the x-axis. We're going to start at 0 degrees. And we're going to go up to 360 degrees. Okay, and then along the y, we're going to assume that it's a unit circle. So we're going to go from like -1, because it can go backwards, to +1. Okay, we could maybe we'll go -2 to +2 so that we can see the whole graph. Let's go -2 to +2. That'll be good. Okay, so there it goes up to 360. Get rid of this now. It's in degrees. Now I'm going to type in y equals sine x to show you what it looks like. Y equals sine is S-I-N for short, x. Okay, so there is the shape of the sine graph. Okay, at 0 degrees, it's 0. At 90 degrees, it's the 1 because it's right up at the top of the circle. Then as you go to 180, it hits the x-axis again, swings all the way around, and it's 0 again. Then at 270, it's pointing straight down along the y-axis because it's y over r, and if r is 1, it's just sine in the unit circle. It's sine y. And then over here, it's 0 again. Now the cosine graph is very similar, but it starts, as we know, the cosine is x over r. So when you start here, x is at 1. When it's laying down on the x at 0 degrees, and then when it goes up to 90, x is 0. So it's going to be shifted a little bit. So y equals cosine, which is cos x. Okay, so you can see that it starts at 1, and at 90 degrees it goes to 0 because there'd be no x component with the vector going straight up and down. At 180 degrees, it's -1 because it's laying backwards. At 270, it's going straight down. Okay, so it's 0. Right, no x component, but just the y component. And up here. So there are your basic forms of the sine and cosine graph. Okay, now what do we call this? Now, if you go back into here, and if I said, well, okay, what if I want to go from 0 to not 360 degrees, but let's say I want to go to 720 degrees. Okay, you can see that the graph is going to repeat itself every 360 degrees, right? Because it's going to go around the circle once, then start again, then start again. Same thing with the cosine. It's going to go around the circle once till 360, then it's going to start again and start again. That length in which it takes a graph to repeat itself is something we call the period of the graph. Okay, and we'll write this down in a minute. Okay, that's the period of the graph. So there's the sine graph, there's the cosine graph for 0 to 270. Now, you can also put these to radians, but you have to use the pi symbol and go 2 pi or whatever. But we'll just use degrees for now. Okay. Okay, well, what about, okay, let's go back to just 360, so it's only one. Okay, and you'll notice it never goes above 1 in the unit circle and never goes below -1. So that is called, that height of this graph, they have a technical term for that, and that's called the amplitude of the graph. Okay, so we're going to talk about the amplitude and also the period. Sorry, guys. So the other thing that we're going to look at here with this graph is you'll notice that right on the x-axis, it kind of cuts the red right in half, and it cuts the blue right in half as well. Okay, that's called the midline. Okay, so there's an amplitude. We'll draw this all out, by the way. There's an amplitude, there's a period, and then there's a midline. Okay, there's a maximum and a minimum. Okay, and that's what we're going to look at in our notes here. Okay. Okay, so let's kind of summarize after we've done this in our notes here. So let's move this over here, and let's do the basic shapes here. Okay, there's our graph. Okay, now if you're using the unit circle, you can say, we'll make this a little bigger here. Okay. Okay, if r equals 1, which is the unit circle, then sine is just the value of y, because it's y over r, right? And cos is just the x, because it's x over r. And if that's 1, anything divided by 1 is itself. So that's handy when we're using the unit circle, okay? Which we use quite a bit. Okay, so let's do a sketch of each graph. So the basic shapes of the y equals sine x graph. Okay, so what we do is we just usually make like a little T. This is what I do to sketch it. Okay, so we take and we make a little T graph. You could do it there, but I'm going to do it here because I'm just going to go. And then what I do is I go 90 around the circle, 180, 270, and 360. So there's our circle corner points, or quad points if you like. Okay. Then we label it. We could say that this is 0, this is 90, this is 180, this is 270, and this is 360 to go around the circle. Okay, and then it'll repeat itself. Okay, so if we draw the sine graph, we know that it goes up to 1 and down to -1. And that's it. And the sine graph is easy. It's just when you're plotting it, sine graph is 0 at 0. We'll do it in green here. 0, then it goes up to 1 at 90, then it comes back to 0, then it goes to -1 at 270. You can always look on the circle if you're not sure. And up there. So then it gives you that sine graph shape. And you can check in between to see what the value of sine is with your calculator. And it's symmetrical like that. So this is the basic sine graph. So we call this length here the period. Okay, it's the time it takes well, not the time. I guess we're talking degrees here. I keep thinking physics here. Sorry, guys. It's the how many degrees or radians before the graph repeats. Its shape, right? Okay, that's the period. Now, this part here, okay, this height, we'll do it in blue here. This to this, or this to this, that's called, we'll call it is called the amplitude. Okay, it's the height of the graph. Okay, this is a max, and this is a min. Okay, and what we call that line in the middle is the equation of the midline. So this line right here, we'll do it in purple. It cuts the graph symmetrically to a bottom and a top half. That's the midline of the graph. Okay, so that's the midline of the graph. Okay, so the midline is basically, for all of these, it's the x-axis right now. It'll change a little bit when we go a little deeper into looking at the typical type of, when we do some analysis type questions, okay? And we look at the period and so forth. Period being how long it takes for it to repeat itself, which would be one full circle, which would be 2 pi radians or 360 degrees. Maximum, min, or highest and lowest values of the graph right here. And of course, the height of the graph we'll call the amplitude. To a max to the midline, to a min to the midline. Okay, the cosine graph is a little bit different, but not much. If we do the cosine graph right underneath, okay, 90, 180, 270, and 360. So the cosine graph is a little bit different in the first part of the circle. It starts at 1 because it's laying down on the x-axis, and the cosine graph is equal to x. So this is going to be the basic cosine graph. Y equals cosine x. So up here we have our 1, and down here we have our -1. Okay, so in cosine, it starts here, and then it comes down, then it goes to a negative, then it goes to 0, and then it goes back up to here again. So the cosine graph, and if we label this, I forgot to label the degrees in there. 90, 180, 270, and 360. So here we have the basic shape of the cosine graph. Oops, let's make it green here. Sorry, guys. Gives you that same smooth curve that you get. The same, except it's just shifted over and starts at a 1 instead of a 0. Okay, again, we still have a max value and a min value. We still have the midline right here. We still have the amplitude. In there as well, and we still have the period. So you'll notice that sine and cosine graph have the same max and min values, even though they start at different places. They have the same period. They have the same equation of the midline. The only thing that's changed is that they cut the x-axis in different spots. Okay? So for summarizing that here, the sine and cosine graphs have the same period which is in our case 360 degrees or 2 pi radians. Do radians, which we haven't done very much of. So they have the same period, they have the same max and min. Which is 1, and min, which is -1, values, and the same midline, in our case is the x-axis. Okay, so that's all the same about them. The amplitude is the same as well. Okay, the difference is where they start. Okay, cosine start at 1 and sine at 0. This then gives different x-intercepts. Okay, so let's see if the let's see. I guess we could give you a couple practice ones. There's nothing really that difficult in here. I was just looking at the book. They don't really have anything that challenging. But if you want to just kind of, even if you do it orally with somebody, and kind of just talk about some of the stuff in there, you can check out page 524. Okay. Let's see. You can just do 2, 3, 4, 5, and 6. Okay, and you can just kind of analyze them. Okay, it says compare the function. So you're just looking at them. If you need to pull out Desmos and have this beside you right here like this when you're answering those questions, you can do that as well. Okay, so that'll be it for today in day 8. And we'll be looking at, tomorrow we'll be looking at graphs of sinusoidal functions and finding amplitudes and periods and all that kind of stuff. And then our very last thing, because this is pretty short, our very last thing is doing transformations of the graphs. So there's only a few more days left in this last unit. Okay, we'll see you tomorrow.